talk a little bit about the test format here. So for the test, you should be able to eliminate the parameter from a parametric function, determine the domain and range of a rectangular function induced by a parametric function. This is just like what we did on the homework quiz, right? Find the parameterization for a line segment. Should be able to plot polar points. Should be able to convert between polar points and rectangular points and vice versa. Should be able to convert between a polar function to a rectangular function and vice versa. And you should be able to answer parametric function story problems in cases where the equation was given to you, similar to what happened in the homework quiz, where I gave you the description and then put the equation together for you and just asked you to do stuff with it. Clarification or questions about any of this for me? Okay, cool. That's pretty clear. Questions about any past work that you have right away? Okay, sure. What's up, Emma?
Could you do number 88?
88? Sure. So you just have like a lot of things to do, it looks like, for this one, right? Because it asks you to do 3 types of symmetries. All right, whatevs. So for the x-axis symmetry, we know we're going to be replacing theta with negative theta. For the y-axis symmetry, there it is. We're going to replace both r and theta with negatives. And the 60-degree point symmetry, we're going to replace theta with theta plus 60. So just kind of knock these out one at a time. R equals 2 cosine 6 times negative theta. 6 times negative theta is negative 6 theta. And then if I use the odd-even identity for cosine of negative theta, that's just equal to cosine. So we're done there. Cool with that. This one is the tricky one. Oops. Negative r equals 2 cosine 6 times negative theta. What's the trick here on this? I forget. That was it. Okay. So here, now before I do that. So this, what I'm going to do is convert this,
Why did you get rid of the negative?
It's an identity. That's an identity, right, from last semester? Okay, so this is the tricky piece. Is this polar coordinate is the same as that one, right? If I take the negative and I add pi to it, that's the same thing, right? So that's what I'm going to use there. Whoa, Mr. Kulik. Sneaky, sneaky. Yeah, a little bit. Okay. And so if I multiply the 6 through, there's that. And then I'm going to use the sum or difference formula for cosine. Okay. Now cosine of 6 pi, that's something we know, right? What's cosine of 6 pi? It's the same as cosine of 2 pi, because those are coterminal, right? Which is just 1. And sine of 6 pi, my pen stopped working on me. I hate you, computer. What's cosine of 6 pi? You guys remember that one from the unit circle?
Cosine is 1 and sine is 0.
Yeah, at 6 pi, cosine is 1, sine is 0. So that's just 0. So that whole piece drops off. So that's what we needed. And then the last one here. That's not a theta, that's just a 60. Okay. So I distribute the 6 through. Oops, I forgot the 2 there. Mr. Kulik, I know, guys, I know. Do the sum of formula for cosines. So that's going to be cosine 6 theta times cosine 360 minus, and then the 2 still distributes through, sine 6 theta times sine 360. What's cosine of 360? It's 1. Sine 360 is 0. That's the identity. Cosine alpha plus or minus beta is cosine alpha cosine beta minus plus sine alpha sine beta. So the symbol for the sum or difference of cosines flips in the identity. So if I have a plus here, I have a minus there. Does that feel okay? Mia? Well, remember what was going to be on the test here, right? Was this one of the things I was going to ask you to do on the test? No. Why do you suppose I omitted this? Because you just so much reliance on identities and unit circles and stuff that I just was like, you know what? There's one less thing, right? Mac.
So for the y-axis,
Yeah.
why could you not have just done distributed the negative and active
So
to the front of it and then just divide it with negative?
well, you can't pull the negative to the front because our That's our odd-even identity for cosines. Right? So if you're doing what you wanted to do, you'd have negative r 2 cosine negative 6 theta. And when you apply that identity, there's no way to get rid of the other negative sign.
So you couldn't just divide negative.
I mean, you can, but it moves it to here. And that doesn't really help you any. It's still not the same, you know what I mean? So that's why I use that other trick there of rewriting it with a positive r, which Mr. Kulik, that was pretty sneaky. You didn't show us that one. Yeah, I know, you don't get to see them all sometimes. Gotta leave some tricks, you know. Ty.
When it comes to finding the main and range,
Yeah.
how do we know if it's bracketed or just
Well, if it's a finite value, if it's going to come from like the t. So like if I'm doing a domain, let's say that my endpoints are a and b, or are 0 and 5, and the answers of those are just whatever, a and b. When I write my domain, since 0 had a parenthesis, the value that results from 0 is also going to get a parenthesis. And since 5 had a bracket, the result that comes from 5 would also get a bracket. That's basically what I think what you're asking, right?
Yeah.
I tried to do that like arbitrary enough that you get the idea. Is that cool? Okay. So it just depends on if the value is included in t or not, in the interval for t. Okay. Anybody else? Yeah, Teeks. 70? So you just want to convert this to rectangular form. Okay. So we'll just multiply both sides by r. R squared is x squared plus y squared. R sine is y, and r cosine is x. Now move everything onto one side. So far, so good. And then we'll complete the square. So what do I have to add to complete the x's? Well, negative 8 divided by 2, so negative 4 squared. And I got to do that to both sides, almost forgot. And then what do I have to do to complete the y's? Yeah. And it's fine to write that as like negative 4 squared and positive 3 squared. Like, I'm just writing it this way so it's easy to see what I did.
Yeah, because the 2ab.
Mm-hmm. Yeah, it's b divided by 2 squared is what we're adding. But yeah. And then that's 16 plus 9, so 25. And that would be your final answer right there. Is that cool? Mackenzie, did I see your hand? You think you got it? Sweet, dudes. Well, I'm going to get out of your way and let you guys work on your review or your homework set or whatever is the highest priority math thing for on your agenda right now. Obviously, if you run into questions about other things along the way, you are welcome to come up and bother me. It's no bother at all. It's called doing my job. Okie dokie. All righty. Get to work,